Grade 9s, what is happening? Today we're doing geometry of straight lines. Now, that's what the lesson is about. We're going to try and find angles, see how we find them. But most importantly, what I think you guys struggle with a lot is telling me, the marker, as the teacher, why I managed to find it. What is the reason behind me finding that angle? And that's what I want you to pay attention to. Right now on the screen, I'm going to show you the different reasons as to why we are able to find these angles, and that's what we need to back up our answers with. It's on the screen now, take note of it. Alright, there are lines, there are angles, and we need to find them. And the question behind this is, find the unknown angles in alphabetical order. So they're actually forcing us to find it in the way that they want us to find them. So this is the reason as to why they're going to try and explore all the different reasons behind why we find angles when we're dealing with geometry and straight lines. Now, my trick to stuff like this is always to look at what we've got in front of us. Don't look at the angles. What I want you to look for are things like parallel lines, lines that are equal in length. Those are the things we should always be focusing on before we get to anything else. Another trick is move the page around. Sometimes we see things differently. So if we're seeing it right now in front of us, we're like, I can't make sense of this. We turn it around, it starts to make sense. So those are things you should look out for. But we're going to get stuck into this right now. I've got angle A, B, C, D, E, and F that I need to try and find in this diagram. So we're going to go through it alphabetically like the question has asked us to. So I'm trying to find angle A. Well, how am I going to find angle A? What is my clue over here? Well, I've got a 20 degrees over here, and I have lines that are intersecting. We know that if two lines intersect one another, the angles opposite them are going to be equal. So that means that angle A is equal to 20 degrees. But what is the reason? They are vertically opposite. So I tell my teacher by putting into brackets, vert, we just write vert, that's all we need to write for vertically, and OPP. That's great mathematics right there. Nice and simple. It's a nice, simple, straightforward, easy one, but this is what we need to get into because that's worth 1 mark, and so is that. If we're able to find angles without proving why we found them, we're not going to get all the marks that we need. So you need to make sure that you're focusing on the reasons, and that's what I'm going to try and emphasize in this video for you today. So that's A. What I'm going to do is I'll go to B and C, and then I'll erase as we keep going. But the other trick that I like to remind my students about is, once you've found something, update your drawing, because then you start to see a lot more. Alright, so I know that A is 20, so I'm going to write 20 degrees in there. It may or may not help me as I go forward, but it's there. Alright, so moving on to B. Now, how am I going to find B? Well, what are my clues right now? I've got 52 degrees here, and it's inside a triangle. I don't know my third angle over here, so I won't be able to use the rule of interior angles of a triangle. I don't know C, so there's no other clues here. There's 20 degrees over here. And as I said before I started, zone out, look at lines. Do I have lines that are equal? Do I have lines that are parallel? If I have lines that are parallel, that's a massive clue. And as we see, I have FD that is parallel to BC. Here's my transversal, and I notice that B and this angle over here are lying on that same transversal with these two parallel lines. So what does that mean? Well, 20 degrees, right, is on the top left of these 4 angles where they intersect, and my B is also on the top left of these angles. And some of you might have been taught all about the F, the Z, and the C, or U, and that makes these two angles corresponding. And we should know, so I'm going to say that B, right, is equal to 20 degrees, because corresponding angles are equal. But what do I need to tell my teacher? Corresponding angles. Corresponding, you can just do that. Alright, I don't even need to do that. I can just do C-O-R-E-E-S. But we'll leave it with an S. Alright, corresponding angles. Now, corresponding angles, alternate angles, and co-interior angles only exist when I have parallel lines. So I need to tell my teacher that I know that they are corresponding angles because FD is parallel to BC. Very, very important. FD is parallel, the sign for parallel is the equal sign just vertically, all right? Is parallel to BC. And that's my rule. That's my reason why I managed to find B. I know it's corresponding, but if I don't put this in, it's not really going to help.
Question.
Oh, we have a question. Yes. Come up to the board. Come up to the board. Come ask me what you want to know. Yeah.
One question that I always get confused with is, what if these markers, the green ones,
Yeah.
are drawn in this direction? Does it mean it's only parallel in this direction, or is it parallel in the opposite direction?
Well, once we have parallel lines, that means that these two lines are never going to touch one another. And they're going to run parallel to each other forever and ever and ever. So the reason why they've done it like this, they could have done it the opposite way. They could have done that as well. It doesn't make a difference. The only difference comes into play is when we talk about how many arrows there are. For instance, if I said to you, Russell, that these two lines are parallel, and then I did this, that means that that line is also parallel to these in mathematics. But the teacher wouldn't do that. They would have to put two of them in and two of them over here to differentiate, to make it different. Differentiate just means to make it different to one another. Now I know that these two lines are parallel, and I know that these two lines are parallel. So that's what you need to keep your eyes open for. But for now, it doesn't make a difference which direction the arrows are pointing. It just means that those two lines are parallel and they will never meet one another. Does that make sense?
Perfect. Thank you.
Brilliant. Cool. Now, we're going to move on to C. But before we move on to C, I need to update B. So I erase B and I update it with 20 degrees. Now you're going to start to notice that things are coming to life now. Because now I've got more clues to work with. So I move on to C. Now, angle C. Bit of a tough one. We've got two lines that are intersecting, but I don't know what this angle is, so I can't use vertically opposite. I can't use angles in a straight line because I don't know what this angle is either. So where are my clues? Well, my clues are going to lie inside this triangle. Now this is one that some people struggle with, and it's called the exterior angle of a triangle. If I know what the exterior angle of a triangle is, that means it'll be equal to the two opposite interior angles. If I know what the two opposite interior angles are, that means them two added together, the sum of the two opposite interior angles, is equal to the exterior angle. So that's my rule. So C is going to be equal to 52 degrees plus 20 degrees. So angle C is equal to 72 degrees. What's my reason? Exterior, EXT, angle of a triangle. Notice I don't have to write triangle, I can just put the shape in there. And that's my reason for C. Great, so now we've outlined what C is. Now we fill it in. Alright, what comes after C? Well, that's D. Now, how are we going to find D? Bit of a tricky one, but again, let's take a step back and look at what we're dealing with. So, I have 72. 72 is the exterior, it's the exterior angle, alright? Let me just use a different color here to highlight that to you. It's the exterior angle, alright? This is the exterior angle of this triangle over here, alright? It's the exterior angle of this triangle. So that means that angle D and angle over here, we'll call it BFE, alright? This angle over here, we don't know it just yet, but 72 is the exterior angle of that triangle. Now, what's interesting about this triangle, what we need to note about it, is that we see these two blue lines here. Now, if they're going to use those lines on a triangle, that means, or any shape, it means that these two sides are equal in length. Aha, that reminds me, this must be an isosceles triangle. So what do we know about isosceles triangles? We know that the bottom two angles of an isosceles triangle, at the bottom of the equal sides, are going to be equal in size. So that means that D and this angle over here, alright, are going to be the same size. So if I was to find D, alright, we'll call this FB, but if this was also going to be the same size as D, let's just call it D as well, not to confuse you. So we know that D plus D is equal to 72 degrees, because the opposite interior angles of a triangle is equal to the exterior angle of a triangle. So now all of a sudden we've got an equation, and we've got 2D is equal to 72 degrees. So what is D? We divide by 2, so D is equal to 36 degrees. Now, interesting part. What's going to be my reason for that? Well, that's going to be the angle sum of an isos triangle. That's my reason right there. Okay? It's the angle inside an isosceles triangle that are equal to each other. So that's my reason, and I've now found D. So what do? I go and I update D, and D is going to be 36 degrees. Right, nice and easy. I now need to move on to E. Now what is E going to be? Well, this is a bit of a tricky one. Because angle E, we could say angles in a straight line, but we don't know what F is. So what are we going to use? Well, let's go back to our parallel lines. So if we look at these parallel lines, I could extend this, all right, extend that, okay, and say that these two angles, all right, are inside my parallel lines, all right, they're inside my parallel lines on the same transversal, so that must mean that they're co-interior. And I know what D is. D over here is going to be 36 because we proved that. So E, angle E, check it out, angle E, right, is equal to 180 degrees minus the other two I have here, so minus 72 degrees. So E is equal to 108 degrees. Makes sense? I think it does. These are my co-interior angles, and co-interior angles add up to 180 degrees. So if I'm going to make my reason co-interior angles, but I can't leave it at that. What did I say about co-interior angles? It falls into the same category as my alternate and my corresponding angles. So co-interior, corresponding, alternate only happen when I have parallel lines. So I need to tell them that I've used parallel lines FD being parallel to BC. And now my reason is finished. So I've now said it's co-interior angles because FD is parallel to BC. Next step, I need to update this. So this is going to be 108 degrees. There we have it. So now I've found E. Let me erase E so we can get down to our last letter, which is F. And then we're done. So heading on to F. It's our last one. And you know what? They've saved the easiest for the end. Because how am I going to find F? Well, we could say that it's corresponding. But let's use one we haven't used yet before. Because angle F happens to fall on a straight line. And they're all around the same vertex. That's where angles meet. Alright? So that means that all of these angles, F plus this one, must be equal to 180 degrees. They are supplementary angles. So all of a sudden, what I'm going to do is I'm going to say that F, angle F, is equal to 180 minus 36 minus 108. Some people might like to say this. This is just the same sum, just done differently. 180 minus brackets 36 plus 108. Some people prefer to add instead of subtract everything. So I'll just stick with this bottom one. So that means that angle F is equal to 180 minus 144 degrees. So angle F is equal to 180 minus 100 is 80. 80 minus 40 is 40. 40 minus 4 is 36. So F is equal to... Now just going back, I don't know if you noted, but I actually made a little bit of a mistake. Because angle F cannot equal 20 degrees. Why? Because I have not seen that these two lines are parallel to each other. So it cannot be equal to 20 degrees. These two lines are parallel to each other, but these two lines are not. They have not stated that. So in mathematics, never take things for granted. We cannot believe things that look like they're 90 degrees. We cannot believe things that look like they're parallel. It needs to be stated in the maths problem. So I've now solved F, and the reason is angles on a STR for straight line. And that's my reason. I hope that this makes sense to you. Go practice some more. Drop me some questions in the comment section below, and don't forget, subscribe. Because if you subscribe now, you're going to keep getting those notifications about all the interesting and really cool videos we're doing leading up to the exams. Good luck.